Now we'll start today's session. Okay. So today I'm solving the doubts, the problems regarding week two assignment. Okay. So slide is visible.
Possible, sir.
Okay. This will solve the doubts, like solve the assigned questions. Not totally, I can't say share the answer because it is live now. I'll just give a hint how you can solve that. You have to solve by yourself. And after that, if you have any doubt, so you can ask me. Okay. So yes, yeah. So the question number one here in assignment two, week two assignment is which of the following is true about temporal coherence in the statement given below? So first option is like the first statement is saying that limits the interference, and second is saying that its the range is between -1 or equal greater than, and it is between 1 and -1 or equal to both as well. So you can see that this temporal coherence, it corresponds that monochromaticity correspond to 0. Second. Monochromatic source correspond to 0, and if it is a incoherent source, then it is called 1 second. Incoherent source, then we can say that it is the range will be like the unit will be 1. Okay, it's correspond to 1. So based on that, we can say that second option is having some problem, and you can select according to that. Okay, any doubt here?
So second statement is false. Is it, sir?
Yeah, it's looks like false only because of that.
0 to 1 is correct.
Yeah, 0 to 1. Okay.
What about the first one, sir? It limits the interference.
Like temporal coherence, that is, yeah, it is true only because it limits the interference. Okay.
Yes, sir.
Yeah. Okay. Then we'll go to the question number two. Here, the question is asked: a fabric array filter has a mirror spacing of 100 micron and a refractive index of 1.5 for the medium between the mirrors. What is the free-spectral range (FSR) of the filter is in terahertz they have asked. So this question is quite like simple. You should know the free spectral range. What is that? So if you have some modes like and so here, suppose we have fabricated cavity. So it is not working. So, okay. This is separate cavity. It will work like this. The rays will go like this and trap inside. Okay. And it will generate the um, a cavity that will like constructive and destructive interference will happen, and that constructive interference will just increase the amplitude, and you'll get, suppose two phases are matching and amplitudes will double. Okay, become double. If you have A amplitude, then after that it will become 2x. Okay, this area, this amplitude. So that's what is it is telling the FSR value. What is happening here? Constructive and destructive interference is happening. So we get modes like this. Okay, just a second. See that my intensity will be quite high. Here wavelength we can see high intensity we can see. This gap between these two intensities, high intensities, called FSR. Okay? And they're asking the free spectral range in terahertz. Okay, the frequency they are asking. I have written here wavelength. You can convert into frequency also. So the FSR is like FSR is equal to P by 2n lambda.
Actually, voice is not clear.
Is it not audible?
Yeah, now it is. Yeah. And previously it was not.
Okay,
It was
okay.
distorting.
Just yeah. Just tell me whenever you are not hearing this, or it is not visible for you. Okay, please. So here, oh, sorry, not lambda. It's a distance. Just mirror spacing. Okay, so you just simply keep here the values like this mirror spacing, this refractive index, and the C value. C is a constant, speed of light. So you'll get FSR. Okay, you have to solve like this question. You got it? This question? Is it okay for you? This question? Understandable? Okay. Then you should. One thing you have to remember this C. We are whatever the uh, unit we are taking, and this micrometer also should be in that unit. Okay, so then only it will be cancelled out. We will get in per second, so it is a hertz. Okay. Now question number 3 is in the question given below there are two statements marked as assertion and reason. So this is a assertion reason kind of problem. Mark your answer as per the code provided below. So assertion is written A. Assertion A is written like reflection from a high refractive index to a low refractive index have a 0 degree phase shift, and reason is written like a reflection from a high refractive index to a low refractive index have a 180-degree phase shift. So this can anybody tell like which could be the answer? Like Somebody has solved this question? Is it solved by somebody? No. Am I audible?
You're audible, but your voice is not that clear to understand what you are saying.
Okay. Uh, now it is audible.
Yeah, now it is.
That some noise is coming.
Sorry?
Some noise is coming. It's clear for you.
Clear, sir. Clear.
Okay. I was just asking about this question number three. Anybody has solved this question, like assertion and reason? So what could be the like probability of like answer? A, B, C, D. So many are there.
Sir, in the reason typed here, second point is reflection from low index to high index. Sir. In the website, it was given like that.
Yes.
In
Okay.
your slide, reason
I didn't
B,
get it. Okay. Okay. This you are telling
high
like
low to
okay, low to high. Okay.
low to high, sir.
Okay. Okay. Maybe it's a question problem. Here low to high. Huh? This
Yes,
thing.
sir. Yes, sir.
Okay. Got it. And this correct is. So are this assertion and reason are like what do you think? Like it's true or false or what? What do you think?
Mm.
Just tell me, is it true or not? Like, as it written like A and R, which one is true and which one is false? Or what is your opinion about true and false? Yes, Abhapati,
Yes, sir.
is
I
it
think low to high results in 180-degree phase shift. That is right.
that is correct, huh?
Uh,
Okay. And what about this A?
A means opposite. That is also correct. Yes.
Okay. And what do you think this is related to each other or
Therefore, B seems to be the correct one. Both A and B are true, but R is not the correct explanation of A. B seems to be correct choice. B.
okay.
B.
Yeah, I think you are right. And this is the uh, right option, I think B.
Yes,
Why
sir.
is like this? Because when that light passes, like suppose you have denser medium and rarer medium, and light passes inside. Okay, so just a second, reflection they're asking. Okay, suppose it is passing like this, reflection is happening. So in that 0 degree phase shift will okay, just high refractive index to low refractive index if it is go. Suppose we have another same thing. If it is going like this, uh, high refractive index medium, and just keep bigger this thing. And the light is going like this and reflecting. So this will cause the phase shift for 180 degree.
Yes,
Okay,
yes.
and if it is we have denser medium this side. So here this rare like refractive index is lesser than like 1 I can say, and this is 2. So 1 is quite lesser than 2. Here same for both same it is same. But here what is happening? The phase shift will be sorry, phase shift will be 5 is equal to 0 degree phase shift. Okay. So this question is saying that option number B will be correct answer. Okay. Next question. This is the match of the following interferometer application and their names. So can you guess, guys, what could be the answer? Yeah, so many people are there. Almost six, five. Yeah. Are you understanding this question? First of all, yeah. So is it? Can you tell about this option number A is there? That is written that used for band pass filter. What does that mean of band pass filter? Like which interferometer we can use here? And what do you think? Why it is useful? You should also know these things. So that's why I'm asking. If it is not you're not understanding, then I can solve that question. Okay. Just first you tell what do you feel about this? Yeah.
Filter won't allow the unnecessary frequencies to pass through.
Yeah. Yeah. So how many types of filters will be there? Like narrow band also there, long pass filter, short pass filter. These things are there. So this application is which interferometer is useful for this application? Can you tell? I shall, I think. I should solve this. So you see here that band pass filter, when you have some cavity, okay, and your light is trapped inside. Just now I showed that. It is trapped inside and generating the constructive and destructive interference. Then you'll get particular peaks will be very high. So many peaks will get. If we have given this like particular space, length and width the cavity, then you'll get a very like like a one kind of filter. So it will just enhance one particular peak in that spectrum, okay, that particular spectrum. So what do you think? Which interferometer can do that? Anybody?
I think band pass filter means Fabry Perret resonator cavity.
Yeah. How it is working? You got it? Like whatever I'm explaining, is it
Yes,
understandable?
mirrors, several mirrors, and
Yeah, mirror also
using
possible
multiple.
if you have a cavity also. Yeah, mirror. Yeah, mirror is also possible. Okay.
Gravitational wave detection.
Yeah. Actually, you can just solve first another options because it is quite tricky, I think, for you guys. Option number B. So sensitive to rotation, you can tell. Anybody? See, option C.
Sensitive to rotation, Sagnac, I think. Sagnac.
So what is happening in Sagna? I'll just show you. Suppose we
Sagnac.
have uh, here you can see that we have one the Sagna cavity. In that, what is happening? If you rotate, then the short actually this the path will become shorter and longer. It will rotate that. Okay, are you getting that? If you rotate that, so that path will change, like shorter and longer it will become. Okay, suppose here some length, the different length is there. Then after rotating, it will be changed. Then it is very sensitive to rotation. That's why it is written here. So option C is the application of first Sagnac rotation, Sagnac interferometer. Okay. Then option D, you can uh, just to guess what could be the answer. Option D, used to find the refractive index of unknown materials, like unknown material or like difference in the refractive index also we can uh, guess through this interferometer. Which could be the answer?
I think Alexander.
So Alexander is the correct option. Okay.
Yes, I think.
And in the last, we just leave that question, option number like in column one, we left a B. So you can now predict that easily.
No,
It will be my question like that. Okay. So now we'll move toward the question number four. This is numerical type question again. So an FBC sensor has a Bragg wavelength of 1550 nanometer and an effective refractive index is 1.48. What is the grating period of this sensor? In nanometer, we have to tell unit is nanometer. You should remember that whenever you are solving the question, you should solve the unit also. Like otherwise, if it is in micrometer or something else, then the
Sounds better.
answer will be wrong. So here you can solve this question by using this equation and setting. Grating period you have asked. So lambda b is equal to 2 n effective and lambda. So here this is called a grading period. So we have to uh, work with this. So you can keep the lambda value here and refractive index written there. Just a second, here some mistake is there. Lambda b is I think b will be small. I think Bragg wavelength.
Suffix.
I didn't get you. What? Can you tell? So, yeah, okay. So just keep this very safe and you'll get the grading period of the sensor in nanometer. Quite easy. Now we'll go to this question number six problem. Which of the following properties is directly proportional to longitudinal coherence length? So it is like just a simple question. Like just okay. So the longitudinal coherence length L C is equal to C P C. Yeah. I see that is longitudinal coherence length. It is equal to 3 how so you can see that is here this is calculate the difference with outputs and according to that you can correct the options. So how is not a specific coherence and access difference? The DFT is how is the DFT is as okay, now question number 7. Find the periods of a UAS with respect to the air efficiency when some series or wavelength 532 nanometers. So you have to find out the variance, this features. You have given the variance and the facility. Can I ask one question to you guys? How many people have solved this problem here? Question number like is assignment is how many events have solved already? Events solved with 12 different types of. So the question of the problem is what a kind of business. The business is approximately the lambda by units. Sorry, it's equal to lambda by 4. You can find out this answer. Is equation for it. Question number 8 is which is the sheet. That's not basic, but calculation is complex. So that is, they are asking that they find the reflections of the windows made by sections and lines and zero of incidence of a special index and x is equal to 3.86 and then is equal to 1.38 and NA and MG is equal to 1. So we have to find R's and the accuracy is in the series after darkness. So the formula here is written is n upon ns upon ns to the power 2n. Then 1 minus 1 sorry 1 plus ns upon ns Yes. So we will capture silent to capture. We will capture. Underscore h and this point underscore x here's a PVC which becomes yeah. So I was like times to the power 6. We solve this equation and let W and minus so 9 and
Introduction again, your voice is not clear.
again it's not coming. Is it my network is proper or not? Like you can see the slides properly.
My network is fine. It is fine.
Now, how it is now?
Better.
Yeah. So this that is how we have to calculate this R resistance rate. The shift service and we calculate with the end. Now question number 9. Here, question is each of the following two statements about optical forms from the words. So the options are like based on high forest interferences, and the second one is received or bandwidth light phase. So can anybody tell like which answer will be less? Like just few or three. And it's quite simple process. In OTT, there's which statement will be filled. Anybody?
One is true. I think second is false.
How you
It's
are going
false,
to
actually, I think.
yes, tell me again. What are this?
No, no. Point number one is true. Point number two is
Okay. And the, I
because it
can't
uses
pronounce
monochromatic source.
the name.
I think that is false because it should be a low coherence information.
So the option number, which option number is correct? English, ABCD. For your brackets at senior price. Actually, this question is for just this that OCC is carrying it is based on the low force interference. So this means that you are reason is that interference of light which occurs over the distance of usage. So that's why based on the low force interference. And option number two it is used for broadband light tools. Yes, yeah. Anybody is telling something?
The option is B, I think. B.
So option actually this option is I told you already that one is false because this is the low.
Oh, one is false. So
Yeah. So like what you have said next is this the interference. It is interference is happening in a meter difference of meter. So this OCP is based on low force interference. And the option number three saying that it's broadband light source. We are taking the broadband because low current means sense gets very multi-layer thing. So it should be a broadband. Okay. I think the option number three is correct here. Yes.
Yeah.
I move towards question number nine. Somebody is telling something. Alex, what's your opinion? Alex.
I'm sorry if I'm reading the question.
So now section number 10 is this is the last section of our GC assignments. Assume that what can be achieved when there are laws of interferences. So if you have lot of interference sources, then which option should be the right is in the line. And it's yes. Here, and just are we here? Can you see your opinion of this? What should be the answer? Or somebody has to? Another is okay there. Please.
More intense states.
Yes. B. Can you try first? Naturally latest. Idea is not serious. Yes, now it is clear.
Yes, audio is clear, sir.
Okay. So there is often this spectral collectivity. Spectral collectivity is the answer. Why? Because with more sources tests failing, the resolution with USCPs of particular colors uh, will be higher. Okay, so the spectral collectivity can be actually where there are a lot of intercurrent process. Okay, quite in this situation, there are this reduced. So now when if you have any doubts, you can ask this. If your family is runs, I think if you have doubts in sessions also, you can ask. Yes. Anybody? Yes. So I think we'll just wind up session today here. If you have any questions or something, then you can ask in discussion forums. Also, you can ask it to me as well. I have a business channel, and that you can start with sales name, and we get a video on YouTube, and there in the comment section also you can ask it. Okay. So thank you for the guidance. If you have any questions, please let me know. I'm teaching this waiting for some 5 minutes time. Then I'll go on that. Yes. Okay. Hello. Yes. Yes, I have to be much. Electrical practice. Yes.